Hey guys, so welcome back. Today we are going to start lesson 18. This is where we're going to start doing double integrals, but now converting to polar. Before we get into any exact examples, we just want to kind of start talking about what strategies we would use to actually convert things to polar. So the first thing I'm going to do here is look at this problem. It's obviously in Cartesian, it's in terms of x's and y's. And so we obviously know it's on a non-rectangular coordinate because again, there's a function right here. So the first thing we're going to do is just graphically look at this and just see why it makes a little bit more sense and why we want to do it in terms of polars instead of Cartesians. So the first thing I'm going to do here is notice that the dx is actually in terms of here. So we're going to look at a xy coordinate system, and we're going to see that our bounds for x is going to be from 0 to 1. So I'm not going to do anything else with that right now, but we're just looking at the region from 0 to 1 for x. Then we're going to remember that this is the equation for y equals, right? Because now we're in terms of y. So we have y equals the square root of 1 minus x squared. And that's going to be our upper bound. And then our lower bound is going to be y equals 0. Well, y equals 0 is just the x-axis, right? So that's just going to be y equals 0. So our lower bound is going to be here. So let's go ahead and figure out what the actual curve is going to be. So this should be very common for everybody. We know that we square both sides and we get our wonderful circle of x squared plus y squared is equal to 1. All right, so that means that we're going to go in just this region and we're going to graph the circle where we have a radius of 1. So we're going to look here at this, right? And we're only looking from 0 to 1. And so let's go ahead and do the other part for a circle. Now, because it's positive, we really only want this region right here. So this is what we want to find the area of. Then there are multiple ways of doing the problem, but another thing is that we're seeing that this is going to be x squared plus y squared. So we can do a couple things here. We can remember that the equation for polars is that x squared plus y squared is equal to r squared. So wouldn't it be awesome, instead of having to plug this in, integrate, we can just say, well, we can rewrite this as the equation of r squared is equal to 1, which means that r is going to be equal to 1 because the radius is always positive. So when we're looking at this region, we start at r equaling 0, and we actually go to r equaling 1. So that's going to be the bound for us in terms of 1. And remembering that theta is the other coordinate system that we're going to be using. So we're going to be starting right here at 0, and we're going to go all the way to pi over 2. So theta is going to be from 0 to pi over 2. So notice that what we're doing here is the fact that we're actually able to take something more complicated and actually rewrite it in terms of constants. So we're going to always make theta our outside. So we're going to go ahead and start setting this up as the integral of, instead of being 0 to 1, we're going to go 0 to pi over 2. And that is going to be our terms of theta. Well, we're going to go ahead and do the integration from 0 to 1, and that's going to be in terms of our radius. And then the other thing that we have to remember to do is we have to put in our extra r whenever we are doing conversions to polars, okay? And then the only thing left for us to do here is actually rewrite this in terms of Cartesian. Well, this is pretty awesome for us to do, friends, because we already know that x squared plus y squared, appears where I want, x squared plus y squared is equal to r squared. So I can take this and do r squared raised to the 3/2 power, which should, guess what happens? And we get down to r cubed. So then all we have to do to finish this problem out is just integrate from 0 to pi over 2, 0 to 1 of r to the 4th dr d theta. So we're going to do some examples. This is just a video to just kind of get an idea of what we're going to be doing in this lesson, right? Just to make sure that you guys feel comfortable in what we're doing here. So I hope this video was helpful for you. This is just, like I said, a really brief introduction to how we can go from conversion of polars and see how much easier this integral is than this integral right here, right? You can still do it. It's just this is a lot more simple and a little bit more logical to solve. So I will see you guys in the very next video. So take care.